Okay, so this is the final problem. We have to design the foundation of the tall building. We have already designed the structural analysis for the building, and we have already done the seismic design of this building. Now we have to design the foundation considering the column loads. Here it is given that the safe bearing capacity is 300 kN per meter square and the allowable settlement is 1 centimeter. So first we have to open E-tabs. Okay, now I'm going to open the tall building design file. Click open. Yes, this is the tall building design which we have done earlier. Okay, so from here what we have to do, we have to find the column loads in the base story, in story 1. So first you can see the analysis is already done and the model is locked. So you can see the tables. Go to tables and analysis results, then element output and select frame output. Here you can see the table for the columns, element forces columns. So you have to right click on that and click show table. Now you have to select only story 1. Now right click on it, select story 1. Now select the output case as dead and live, because we only need dead load and live load. Click apply multiple item filter. Now select station 0. Click equal to 0. Apply filter. Now we can see C1, C2, C16, all 16 columns, the dead and live loads under all these columns are given here. I have already saved this table in an image file, so this is the image file. I have already saved it. So how do you know which is column 1, column 2, column 3, C16, which are these? Go to model, select structural objects, now select story 1, I think. Okay, now if you select C1, you can see this column is selected. So it is C1, C2, C3, C4, C5, C6 and so on. Click structure layout, select stories, and in story right click story 1, select show story 1 only. Click the 3D view and select show story 1 only. Now you can see only story 1 is selected. Okay, Now when you select column 1, you can see clearly it is the first column and it is 500 into 500 column. Same as C2. C2 is 500 into 500. C3 and C4 are also 500 by 500. Yes. C6 is 600 by 600. C6 and C7 are 600 by 600. And C10, I think. Yes, C10 and C11 are 600 by 600. Yes, C10 and C11. All the rest are 500 by 500. Yes, 500 by 500. So only C6, C7, C10, C11. These 4 columns are 600 by 600 and all the other columns are 500 by 500. So we have to note that. Okay, now go to define material properties. Here you can see M40 concrete is selected and HOSD 500 rebar material are considered. So we have to incorporate in these two materials in Safe software. So open Safe software. Okay. Okay. Now go to File, New Model. Select the design code, the IS 456 to 2000. In Design Preferences, go to minimum cover slabs, and both the top and bottom covers are 50 mm each. So type 50, and preferred bar size here we are assuming 22 mm. Click OK. Now go to modify show in units. Make sure metric defaults are set. Click OK. Now select grid only option. Now in the ETAP software you can see it has 18 meter into 18 meter plan. The grid line in X and Y direction both are, you can see. The columns are spaced 6 meter in 6 meter interval. So there are 4 columns in each direction. So 18 meter. So we have to select the grid lines as 19 in X and 19 in Y direction, and the grid spacing are 1 meter each. Click OK. Now the grid lines are drawn. Now we have to define the materials. So first we are defining M40 grade concrete. You can see the properties of M40 grade concrete. In ETABS, go to define material properties. In M40 material, select modify show material. You have to put the details in Safe software. Okay, so weight per unit volume is 25 kN per meter cube. Okay. Click add new material. Material name is M40. Material type is concrete. Weight per unit, volume 25. Modulus of elasticity, you can see 31,622.78. 31622.78. Zero point zero 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 55. It will be 40. You can see the compressive strength FCK. Yes, it is 40. Okay, so M40 concrete is defined. Now we are defining the rebar material, which is HYSD 500. Yes, 500. It will be, I think, 77. It is 200,000. It is 500, and I think I've written right. Okay, it is 77, 200,000, and yes, 500, 545. Okay. Now click OK. Now the materials are defined. Hit OK. Now go to slab properties. Now we are going to add a new property for the footing, for the mat foundation. Okay, so name is at mat. Mat. Material is M40. We are assuming the thickness as 600 mm. Okay, and you can change the type as mat. Click OK. Now we have to define the soil subgrade properties. Now in the problem statement, you can see the safe bearing capacity is 300 kN per meter square and the allowable settlement is 1 semi. So the soils, the K value will be soil subgrade properties will be it will be safe bearing capacity by allowable settlement. So 300 by 1 centimeter, it will be 3 into 10 to the power minus 4. Sorry, minus 4. 3 into 10 to the power 4 kilonewton per meter square. Kilonewton per meter. Okay. Click modify soap property. It will be 3 into 10 to the power 4. 3 to the power 4. Click OK. Yes, 3 to the power 4. Now click OK. Now go to define. You have to define the column properties. Before that, we are checking the load patterns, load cases, and load combinations. The load patterns are dead and live load. It's okay. The load cases are linear static, which is okay. Now we have to define the load combinations. Click add new combination. This is for the ultimate load. Here both the scale factors as 1.5 and 1.5. Click strength ultimate option and click OK. Now go to add copy of combo. Now here scale factors are 1 and 1. Click the other 3 options. Now click OK. Both the service load and ultimate load combinations are set. Now go to define column properties. Now here are 2 columns. You see 500 into 500 and 600 into 600. So we are defining 2 column properties. One is 500 into 500. Material is M40 500, 500. Click OK. Now we are going to add copy of that property. Column 600, 600 into 600. Change the thick 600 into 600 rectangular. Okay. Now the two column properties are set. Click OK. Now we have to define nothing. Okay. So now we are going to draw the footing. So select draw slabs areas. Now remind that we will extend the footing area by 2 meter later. Okay, we will extend the footing area by 2 meter later in all the sides. Property is matte is selected, so we have to do nothing. Click the top left point. You can say 18 meter is shown, so you have to draw the square basically. Okay, the plan is drawn. Now we have to extend the footing. Click the footing. Yes, the footing is selected. You can see 4 edges are selected. Now go to edit areas and expand shrink areas. Offset value is 2000. If you want to reduce the area, you have to just put a minus sign before the value. Okay, now the footing area is drawn. Now we have to draw the columns. You can see again there are 16 columns, and C6, C7, C10 and C11, these 4 columns are of 600 into 600 mm. You can confirm this by going to E-tabs. C6, yes, C6, this column, C7, C10 and C11. Okay, so first we are going to draw the 500 into 500 columns. Select draw columns. Now property below will be none and property above will be 500 into 500. Height below is 0 and height above we are assuming 2 meter. Now this will be column C1. Okay, C1. After 6 meter it will be C2, C3, C4, C5. Now you see C6 and C7 both are 600 into 600. So we'll go to direct C8. Now C9, C10 and C11 are 600 into 600. So we'll be drawing C10, 11, 12, C12, C13, 14, 15, 16. Okay, now we are going to draw the 600 into 600 columns. C7, C8, C10, C11. Okay, just click escape. Okay, all the columns are drawn. Now we have to assign the soil property. So select the footing area. You can see 4 edges are selected. Go to assign, support data, soil properties. Select the soil one and click OK. You can see the soil properties are before we have to draw the design strip. Okay, you can draw later. Click draw design strips. Here both L1 and L2 are 18 meter. The formula of column strip, the width of the column strip is 0.25 L1 or L2, which is less. So 0.25 into 18, it will be 4.5 meter. So we'll take 4 meter. We'll take 4 meter. 4 meter. Strip layer A, which is in X direction. So carefully draw the design strips. Okay, all the column strips in A is complete. Now select B. You have to draw this very carefully. Okay, all the design strips are drawn. Click escape on your keyboard. Now you can see the design strips. Select set display options, and in the design strip objects, select the 3 boxes and click OK. You can see the design strips. Now click this set display options again and untick these options. The soil data is already assigned, so you have to select the rebar material in the footings and the strips. You can see soil property is selected. Click on design, rebar material, change this to HOSD 500. Click OK. Now select the strips one by one. Okay. Change the rebar material HOSD 500. Always check the selections are right or not. You can see a yellow blinking line is there, so the selection is right. Okay, done. So the rebar materials are also assigned. So now what you have to do, you have to assign the loads. Now here's the tricky part. Okay, so okay. Okay, so we have to assign the dead and live loads. Okay, this is column 1, C1. Okay, I am doing one by one. First, I am assigning the loads to the 500 by 500 columns. After that, we will be assigning the loads of 600 by 600 columns. So first, C1. Okay, select the middle point. Go to assign load data and point loads. Now the dead load is 1671.0886. 1671.0886. The dimension is 500 into 500. Okay, click OK. Now click the point again, go to assign load data, point loads, go to live. What is the live load? The live load is 788.7176. 788.7176. It will take so much time. So okay, click the second column, select assign load data, point loads, select dead. Dead load for C2 is 2754.8313. Okay, select the point again, click assign load data, point loads, select dead load, live load. What is the live load of C2? Live load is 1454.3733. Click OK. Select the column C3. Go to assign load data, point loads, select dead load. What is the dead load of C3? 2534.724. Okay. You can select. You can press Ctrl J to select the previous point. You can see one point is selected. Okay, you know what? No, it's not. Okay, go to assign load data, point loads, C3 dead load is given, right? Okay, now live load. What is the live load? 1322.9777. You don't have to give the actual values, but I'm giving it anyway. Select column 4, assign load data, point loads, live Okay, dead load of C4 is this is the huge value 906.8399. Okay, it is the dead load. Select, press Ctrl J, assign load data, point loads, live load. Live load is 437.8733. Okay, now select column 5, C5. Yes, C5, go to assign load data, point loads, select dead load. C5 dead load is 3018.4693. 3018.4693. Okay, click OK. Select Ctrl J, assign load data, point loads, live load. Live load is for C5. C5 live load is 1535.3702. Okay, click OK. Now C6, C7, these two are 600 into 600 columns, so I am leaving it for the last. So go to C5, C8. Okay, C5, C6, C8. Okay, go to assign load data, point loads. C8, what is the dead load value of C8? C8 2529.7707. Okay, okay, Ctrl J, assign load data, point loads, live, C8 live load is 1323.716. Okay, now select the C9 column, go to assign load data, point loads, live load. For C9 dead load is 2868.2622. Ctrl J, assign load data, point load. Oh, sorry. Select the point. Yes, one point is selected. Assign load data, point loads, C9, right? Live load. What is the live load? 1425.8927. You have to give these values very cautiously because mistakes might happen. Okay, so C10 and C11 columns are of 600 by 600, so we will be assigning the loads later. Now go to C12 column, select it and select the middle point. Go to assign load data, dead load, and C12 column, right? C12 dead load, which is 2728.6355. Click OK. Now click Ctrl J, assign load data, point loads, live load. What is the live load in C12 column? 1454.909. Click OK. And now go to C13 column. assign load data, point loads, date load, C13 942.5104. Control J, assign load data, point loads, 94. What is the live load of C13 column? 448.6154. Okay. I know it is very frustrating, but we have to carefully enter the data. Select dead load. This is C14 column. So C14 dead load for C14 is 2589.9756. 2789.9756. Okay. Control J, assign load data, point loads, live load, C14. Live load of C14 column is 1338.8039. C15, dead load C15 2751.5882. Control J, yeah, 1 point selected. Okay, go to assign load data, point loads, C4, C15, yeah, to dead load is also already assigned. You have to assign the live load. What is the live load of C15? 1460.8947. 1460.89. Okay. C16, go to assign load data, point loads, select dead load. What is the dead load of the last column? 1603.1353. Live load 770.1662. Oh, sorry, 1662. Okay, the date and live loads of for all the 500 and 500 by 500 columns are assigned, and now we have to assign the loads for these C7, C8, C10 and C11 columns. So select C7, no, C6, C5, C6. Okay, C6, go to assign load data, point loads, select dead load, and remember to change the punching shear area, which is 600 by 600, which is the area of the column. The dead load of C6 is 4689.2709. Again select the point, go to assign load data, point loads, live load. Which is the live load for C6? 2704.4339. Okay, now select C7, assign load data, point loads, C7 4328.576. Control J, assign load data, point loads, C7. Okay, C7 live load is 2507.099. 2507.099. Okay. Now okay, so select C10, go to assign load data, point loads, dead load. Dead load of C10 is 4426.96 9679. Okay, assign load data, point load, live load for C10, it is 2529.6551. Okay, select the C11 column, go to assign load data, point loads, select dead load. The dead load of C11 column is 4475.4861, right? Again select the point. I think, okay, select the point only, load data, point loads, dead live load. This is the last load. Okay, C11 2616.5021. Oh, okay, all the loads are assigned. I think all the loads are assigned. You can check by right clicking in the middle point of the columns, all columns. In the loads you can see all the dead and live loads are assigned. All the dead and live loads are assigned. You can also select the 3D view, and select the extrude view option. Yes, you can see the point loads, live loads are shown here. Live loads, the live loads for all the columns are given. Now go to show loads, select the dead loads. Okay, and you have to also select the show loading values option. Okay, the dead loads and live loads all are assigned. So deselect the extrude view option and go to plan view. Now what is left is to run analysis. I think everything else is done. Yes, everything else is done. So now click on run and run analysis. You have to save the model, final project. The analysis will be okay. The analysis is done. You can see the displacements values here. All the displacement values are shown here. Go to display, go to run and run analysis and design. Okay, the analysis and design is complete. Go to display, so punching set design. You can see most of the values are greater than 1. So you have to increase the slab thickness again, the foundation thickness, mat footing thickness. Unlock the model, go to define slab properties, matte, modify show property. Now we are going to increase the thickness to 900. Click OK. Now click run analysis and design again. Go to display, so punching sear design. Again you can see the values are greater than 1, these 4 columns, so you have to increase the thickness of the slab again. Increase the thickness to 1200 millimeter. Okay, now click run analysis and design. Go to display, so punching sear design. Now you can see all the values are less than 1, so the design is okay. You can also see that strip forces for suppose load dead load. You can see the moment. You can see the moment in both the layers. For load combinations also you can see the moments, shear forces, okay, everything you can see that. You can see the strip forces for load combination 1. Select one layer. This is the strip forces, shear force. Okay. Now go to slab forces and design. You can see the maximum moment. This is the maximum moment. Okay. Now go to display. So crack widths for dead load, and select the slab bottom face. Click apply. This is the crack width in the bottom face of the matte foundation. You can see the crack widths in slab top face. You can see in both the faces the values are something into e to the power 3, e minus 3, that means 10 to the power minus 3. So the cracks are negligible. Go to display, so slab design. Click impose minimum reinforcing. You can see the reinforcement details for column strip A. Now select layer B. You can see the reinforcement in column strip B. Okay. Now if I check the okay, I think all the okay, you can see the statistics. Okay, for every design strip the status is okay, so the design is okay. Go to run, click run detailing, select the 3 options and click OK. Now I can see the detailed drawing of the foundation. Expand the drawing components views. Go to slab views and rebar table. You can see the rebar information here. Rebar schedule, bill of quantities. Okay, you can see all the information here. You can see the rebar plans, top and bottom rebar plans, and all rebar plans here. Now this is the elevation view of the river, how the rivers will be positioned in elevation view. It is also there, section 1 and section 2. And the reinforcement profiles for layer A and layer B. Layer A is in horizontal direction and layer B is in vertical direction. This is shown. You can see the drawing sheets also, but you cannot print those because it is the evolution version, so you cannot print those. You can place the drawings in the middle portion, I think. Yes. Anyway, this is the detailing portion. You can see all the informations here. So there it is. This is the final project, and the design and analysis of the mat foundation of the previous tall building, which we have already designed for structural analysis. We have already done structural analysis, and this is the foundation design. This is the final project of structural analysis and design using ETABS, SAP 2000 and SAP 2000, SAP 2016. So this was an very interesting course. I mean, it is an excellent online course, and I have learned a lot. So thank you, and thanks for watching.